Scientists at the University of California, Davis built something that breaks every rule about how robots should work. This machine jumps continuously using only light as power. No motors exist inside. No processors run calculations. No batteries store energy, no electronics control movement. The robot operates purely because of what it is made from. The material itself does all the work. The secret lies in liquid crystal elastomers. These rubber-like materials physically bend when light hits them. That bending motion stores elastic energy inside a curved beam built into the robot's body. Light keeps hitting the material, and energy keeps building until a critical point arrives. Then the beam snaps back violently into its original shape, releasing all stored energy at once and launching the robot upward through the air. But here is where the system becomes truly clever. While the robot flies through the air, its own body blocks the light source below. That creates a shadow across the material, which cools it down and lets it return to the starting position. The robot lands, light hits the material again, and the entire cycle repeats automatically. Light bends material, energy builds, beam snaps, robot jumps, shadow resets the system. The physics of light and shadow create a feedback loop without any computer involved. Researchers expected maybe a few jumps before the system failed. Instead, testing produced 188 continuous jumps without electronics. Even more shocking was the strength. This robot weighs around 300 milligrams, which is almost nothing. Yet when researchers added weight to test limits, they discovered it could operate while carrying loads up to 1,700 times its own body weight. The motion comes from something called snap-through instability. The material stores strain energy until it suddenly releases through rapid deformation. The robot does not need sensors to know when to jump. Its geometry and materials handle sensing, actuation, and reset all by themselves. Professor Wenzhong Yan from UC Davis leads this work, and his research focuses on mechanical intelligence. Instead of building smarter machines through more electronics, the goal is embedding intelligence directly into materials themselves. Applications become obvious fast. Tiny robots like this could carry environmental sensors and move continuously across terrain, forming distributed networks that detect smoke or flames during wildfires. Because they do not rely on traditional electronics, they could operate in collapsed buildings, underground tunnels, or radioactive environments where conventional robots fail completely. While some researchers experiment with intelligent materials, others discovered something unexpected about rice. Scientists studying granular materials noticed that packed rice grains behave very differently depending on compression speed. Slow compression keeps the rice strong and structured. Rapid compression causes friction between grains to drop suddenly, making the material weaker. This effect is called rate softening. Engineers realized they could use this behavior. By combining rice with other granular materials that behave oppositely, like sand that becomes stronger under rapid loads, they created entirely new composite materials called metamaterials. These materials automatically change their mechanical behavior depending on how they are stressed. Under slow pressure, they stay stiff. Under sudden impacts, they bend or collapse. All of this happens without sensors, electronics, or active control systems. Dr. Mingcha Liu from the University of Birmingham explained the concept clearly. Instead of programming machines to respond to forces, engineers can let the physics of the material decide how the structure reacts. Robots built from these materials could be lighter, softer, and safer, while still adapting to their environment automatically. Protective gear like helmets or body armor could stay flexible during normal movement, but instantly stiffen during sudden impacts. Now robotics takes an even stranger turn. A German defense startup called Swarm Biotactics has been developing cyborg cockroach swarms designed for military reconnaissance. This is not a lab experiment anymore. The company recently confirmed that systems have already been field tested with paying NATO customers, including German military units. Each cockroach carries a tiny electronic backpack that includes sensors, communication modules, and control electronics. Movement is guided through low-voltage electrical impulses delivered through a neural interface connected directly to the insect's nervous system. Those electrical signals allow operators to steer the cockroach through environments where traditional robots simply cannot go. Instead of operating individually, the insects move together as coordinated swarms. Specialized software manages communication between multiple units so they operate like a single reconnaissance system. The insects used are Madagascar hissing cockroaches, chosen because they are durable, capable of navigating complex terrain like rubble and tunnels, and able to carry payloads of about 3 grams. That payload capacity is enough to support miniature sensors and encrypted communication modules. The company's CEO, Stefan Wilhelm, described the idea as a completely different scaling model for robotics. Traditional machines scale through manufacturing. These systems scale through breeding. In other words, the swarm can grow naturally instead of being built piece by piece in factories. So far, the startup has raised around 13 million euros, including a 10 million euro seed round and 3 million in pre-seed funding. That funding is supporting expansion across both Germany and the United States. Meanwhile, traditional mechanical robots are advancing rapidly. Chinese robotics company Unitree recently unveiled a powerful quadruped robot called the AS2. The robot weighs about 18 kilograms and can reach running speeds above 5 meters per second, which is roughly 11 miles per hour. Despite that size, it can support a standing payload of 65 kilograms or around 143 pounds. Its mechanical design includes 12 degrees of freedom powered by high-speed motors and precision-crossed roller bearings. This allows the robot to climb stairs up to 25 centimeters high, traverse slopes up to 40 degrees, and mount platforms as high as 50 centimeters. Power comes from a 648 watt-hour lithium battery with 15,000 milliamp hours of capacity. When unloaded, the robot can run for more than 4 hours and travel distances over 20 kilometers. Even while carrying 15 kilograms, it can still operate for more than 2.5 hours and travel around 13 kilometers. The robot is built for harsh environments. It carries an IP54 rating for dust and rain resistance and can operate in temperatures ranging from -20 degrees Celsius to 50 degrees. Higher-end versions include advanced LiDAR sensors with 64 to 128 scanning lines, along with Wi-Fi 6, Bluetooth 5.2, cameras, speakers, and microphones. One standout feature is Unitree's Intelligent Side Follow system, which allows the robot to track a person with centimeter-level positioning accuracy. And in one of the strangest applications yet, researchers at Kyoto University recently introduced a robot called Buddharoid, designed to assist in Buddhist temples. The robot runs on a chatbot system called BuddhaBot Plus, built on ChatGPT, and is mounted on a Unitree G1 humanoid platform. It can bow respectfully, perform prayer gestures, and answer questions about Buddhist teachings. During demonstrations, the robot responded to questions about relationships and emotional balance using Buddhist scriptures. Japan has already experimented with robotic clergy before. A robot named Mindar has been delivering sermons at the Kodai Temple since 2019. The reason for this direction is actually quite practical. Japan's aging population and rural decline are leaving many temples without enough priests or followers. Robotic assistants may help maintain religious traditions while human clergy numbers continue to shrink. So, here is the question worth asking. If robots start doing our jobs, fighting our wars, and even answering spiritual questions, what exactly will be left for humans? If you found this video helpful, make sure to like, subscribe, and hit the notification bell so you never miss our latest AI and robotics updates. For more cutting-edge tech content, check out AI Tech Academy, where we break down the technology shaping tomorrow. Thanks for watching, and I'll see you in the next one.